So here's a question for you. Have you ever compared the candy you get on Halloween with your friends? My sister and I, a bit competitive in the sport of Halloween candy hunting, we both had preferences of which kind of candy we hoped to get in our buckets each year. And as for me, I love gummy bears, and every once in a while someone would have them mixed in a big bucket, and I remember watching with intense focus the hand that picked out the candy hoping for gummy bears. Getting those gummy bears was always total luck. Total chance. Well, unless of course the entire bucket they had was actually gummy bears, but that would not be luck. No, that would be pure bliss. But that's never happened to me yet. So why bring this up? Well, what if instead of candy we were talking about insects? And they weren't in a Halloween bucket because that'd be kind of gross. They're on the sidewalk. And when you're scooter riding through the neighborhood on Halloween to collect candy because scooters may or may not be our super awesome childhood mode of transportation, you squash some. Accidentally, of course, because you like insects overall. Were the ones that survived better adapted? Did they have some special ability to foresee events or to move your scooter away from them? Well, assuming they were all just there on the sidewalk in the path of your trick-or-treating, then no. In this random event example, the survivors were not better adapted. They were lucky. It was chance. And the ones that were squashed were, in this case, at the wrong place at the wrong time. And that's what genetic drift is. Genetic drift can change allele frequencies in a population. Remember, alleles are a form of a gene, but genetic drift is random, unlike natural selection. Recall that in our natural selection video, organisms that have traits that result in high fitness are able to pass those alleles on to their offspring. This is where that survival of the fittest comes into play, but not genetic drift. With genetic drift, the organisms aren't necessarily more fit. They just have won the game of chance. So let's look at a representation of genetic drift known as the bottleneck effect. I always like to remember this one by focusing on the word bottle. Well, let's say that we have a bottle here and we fill it with our Halloween candy. If we shake it out and we only get a few of the candy pieces, does it necessarily represent the whole bottle as far as the candy frequencies you got out? Nope. In fact, one of the types of candy pieces isn't even there. That type is totally eliminated. We'll consider a natural disaster, such as a forest fire. The surviving organisms weren't better adapted. They were likely just in an area where they weren't directly affected. But the survivors don't happen to represent the original population, so there's definitely going to be a new allele frequency among the surviving population. Bottleneck effect. Another time to see genetic drift is when you're talking about the founder effect. In this case, you may have organisms that have founded an island or some new area. The few organisms that arrive to start a new population do not necessarily represent the original population that they came from. Let's take a case where maybe some seeds that are dispersed by wind end up in a new area that happened to be one that was ideal for their growth. This new population grows. Well, those seeds that landed in this new area may not necessarily represent the original population of plants from which they came from. It's a random sample. Founder effect. In summary, genetic drift can make some big changes to allele frequencies, and it's a mechanism for evolution. So one last thing. Which type of population do you think would be more vulnerable to genetic drift? A big population or a small population? If someone is just doing some intense candy hunting and by accident scooter rides over a few insects, look at the results in the small population versus the big population. As you can see, this random event has the potential to cause more change from the original in the small population. See, there weren't as many representatives there in the first place. So in many incidences of genetic drift in populations, the impact on small populations is especially significant. Well, that's it for the Amoeba Sisters, and we remind you to stay curious.